Numero uno. What am I doing? Add 5. Simultaneous that. With that, I can do what? Subtract 7x. That's a red flag after the first step. Oh, you brought everything the other way? Oh. You might have made it through. We'll see. All right, so negative x, right? Negative 1x. And we have less than 9. Next step. Multiply both sides by negative 1. If you decided to divide by negative 1, that's also okay. But in either event, you have to remember to do what? Flip the sign. Change the direction of the inequality. All right. All right. So, yeah. You can get there. I mean, you can take a different first step. Now, express the solution in set notation. So we have to do that, and then graphically on the number line. They didn't say to justify the steps with a property of inequality, but if they did, our first step would be justified with what property of inequality? Oh, wonderful. Addition, subtraction.
Of equality.
Yeah, addition or subtraction, POI. Either one is fine. Because subtraction is just adding a negative. So if you say addition POI for subtraction, that's fine. This one would be what? Just think about what we did. We multiplied, multiplication POI.
Wait, since you multiply by a negative, don't you switch?
Oh, wait, I thought I screwed something up. No, I didn't. Okay, so, sorry, finish your sentence.
Don't you switch the, like the symbol other way? Oh, didn't see that.
All right, so we're always going to have that difference in what I'll accept and what the state will accept on the Regents exam. I'll accept if you want to scale your number line around the important value, which is in this case negative 9, and just give me 1 or 2 values in either direction. So like negative 10, negative 8, just to establish the scale. That's all I need. There's literally one person in the entire state in terms of math teachers who is not allowed to grade your Regents exam. You know who that is? You. Me. All right, so what I will accept is not always as important as what anyone would accept.
Our all-powerful overlords.
Exactly. So, if you're in doubt, and you should be, during the Regents, and you'll have plenty of time on your hands, throw in all the numbers. But for me, these 3 are all I need. Now I just need my my whatchamacallit, set notation. So variable x, such that x has to be greater than or greater than negative 9. Squiggly brackets. All right. So I say such that, you might say so that, or knowing that, or having x be only greater than negative 9. Make up a different meaning for this if you want. You don't have to call it what I call it. It just has to be there. Number 2 looks deceptively difficult. It's like, oh, where does x squared come from? But what's actually the first thing that happens with that x squared? We're not going to take the square root. We're going to subtract it because it's connected through addition. And then what happens? It cancels out. You're then going to distribute. Yeah, I'm going to rewrite though. All right, so that's something you can just kind of rely on. It's kind of nice. If you have a common term on either side of an equation or an inequality, and it's only connected by addition or subtraction, you can cancel it. You don't even have to show this step. I just put a strike through the x squared on both sides. And then that's the end of that. So the hard part of the problem just went away. Now it's mere child's play. We could distribute. I heard that. That's fine. But I could also do what? Divide by -2. Cancels it out on the left, and you're only left with an x minus 1. On the right, oops,
Oh, you got the flippy.
I sure did. So, meh. Good thing you were there. Needed that support. All right, so we divided by a negative, so we flipped the sign. The sign was going to the right, now it's going to the left. And now I'm just one step away from having it. I'm just going to add a 1 to both sides. So boom, shaka, laka. All right, so we have our answer in inequality notation, but I want set notation, which is just the jazzier version of it. And then I want to plot my solution. So let me get a -2, surrounded on either side, hopefully correctly. One value less, one value more. We try to stay with integers on the number line. Even if you get a fraction answer, integers are where you want to go. Then you estimate where the fraction would fall within that number line. All right, so I'm going to the left, but also including the -2. Some people do it right on the number line. I like to do it above because I think it looks too messy if I do it on. Just don't do it too far above, because then I might lose it with your, it might get merged with your work in some way.
Do we have to do it above?
No, you can do it on the number line if you want. Yeah, some people like to do it that way, and that's totally acceptable, satisfactory, and okay. I mean, I'm not going to associate the word awesome with it, but it's all right. It works. Gets the job done. Interval notation. All right, so that's today's lesson. You'll see a lot of the problems that we work on in today's lesson and homework will be related to stuff that we've done before. We're just adding this little tidbit. Honestly, I would say that this set notation here should be really strong motivation for you to learn interval notation, because interval notation is much simpler when you're writing your solutions. All right, so interval notation, an interval is a set of all numbers between endpoints. In interval notation, the bracket symbols are used to include an endpoint in an interval, and the parentheses symbols are used to exclude an endpoint from an interval. All right, so an interval that extends forever in either direction would be going from -infinity to +infinity. All right, so our interval notation, we have some possibilities here, at least to get us started. There's other variations, but these are the popular ones. You could have two values bracketed off, in which case we're going between those two values, starting at one, stopping at the other, and including them both. You could have parentheses bracketing them off, starting at one, stopping at the other, but excluding them both. So everything but those two values. Or we can involve some kind of infinity. I think it makes more sense when you start incorporating particular examples. So here's one, but we'll do some together. The lower end point is 1, and it's a solution. We did some algebra, behind the scenes, we got an answer. Part of that answer was that x could be equal to 1, and any value more than 1. So the answer was x is greater than or equal to 1. Right? So that's telling me that I'm starting at 1 and going up to +infinity. All right, because that's telling me that my arrow is never going to stop. It's never going to stop being an arrow, I guess. It is what it is. All right. So we're going to continue on and on and on. Just when you think you got to the last number, keep going one more. And if you could have infinite time, then you would get to that last value in the number system. But since you can't, You'll never get there. But we're starting at 1 with a bracket. If I had an open circle here, I would put parentheses, but I don't, so I won't. All right, so let's take a look at the next page and some more particular cases. So we want to go from inequality to interval notation. We want to be fluent with this because I can promise you, you get down the line, you know, pre-calc, calculus, even algebra 2, you're going to be living in the world of interval notation. And if you're still struggling with the relationship between the greater than symbol and the brackets, for example, then you're kind of behind the curve. So you don't want to be there. So we want to get good at it now so we don't have to worry about being nervous later, I think. And I think you agree for the most part. It's kind of hard to visualize your junior year and senior year selves right now. But, you know, kind of like if you were to give a person in the library, you know, you're in the library and you're given a teacher who asks you to be quiet. If you're giving that teacher a hard time, it's kind of hard for you to conceptualize that 2 years or 3 years from now, when you walk into, let's say, a social studies classroom, you walk in and you say, oh crap, that teacher works here and is now my teacher. And I was mean to that person. It's gonna be a rough year. You know, I only say that because I had a couple of experiences. It was very rewarding. It was like 10 years ago. I had a study hall, and I had a bunch of students in that study hall that just gave me a hard time on a daily basis. And I played the long game. I was like, don't worry, you're gonna be my student at some point. And then what? And then they walked in. It was almost 4 years later, AP Calculus, the hardest class we offer here. They walked in the door, took one look at me, and they said, oh, S word. He's our teacher now.
Got him.
And I was like, that's like telling a joke and then waiting 4 years for the punchline. Like that, it was so great. I was like, I know you too. Sit down. And then I was nice to them after that. It caught them so off guard. But anyway, that being said, it ties into this because you look at this and you say, we're gonna focus on this for a little bit now, and then we'll leave it alone for a little while. Then we'll come back to it and you'll be like, oh, we actually needed to know that. And then we'll leave it alone for a while, then come back to it again. And you say, oh, I really should probably get to know this because it seems to be a recurring theme. And then that's how it's going to be. And then in geometry, you'll kind of skip over this concept for an entire year. But then in Algebra 2, you'll come back in and like day 2, you'll be expected to know this. So very important stuff. I can't emphasize that enough. Anyway, that being said, it's pretty easy as long as you know what the brackets and the parentheses mean. So I have an open circle. An open circle at an endpoint. All right, that's going to correspond with parentheses. Put parentheses around whatever that endpoint is, 4. Then we want to indicate with a comma that it's an interval of values or a range of values, although we don't use the word range, it just seems to make sense. A set of values starting at 4 and ending somewhere, but in this case it never ends. Infinity always gets parentheses, always. So never put brackets on infinity, ever. If you do, you're losing credit. All right, the rationale behind it is brackets contain a particular value. So the minute you tell me what number infinity is, you can put a bracket on it. All right, anybody know what number infinity is? It's infinity, but what number is it? 168,422? No, bigger than that, right? Throw a couple zeros on that. Not even bigger. More zeros? Yeah. Keep going, keep going, keep going. You can keep putting more things on. If I had, you know, like a basket of fruit, the infinite fruit would mean like I have that basket and I can never stop putting fruit into that basket. Over to infinite fruit. All right. So there's no numerical value associated with it. It's just a symbol, parentheses. Anything that has a solid numerical value, maybe it's included, maybe it's not. In this case, it's not. What you need to be careful of, and this is very important, some of you, regardless of how many times I say this, I don't want this to become a self-fulfilling prophecy, but I'll say it anyway. This is not the same as 5 with a bracket to infinity. That's so important that you understand that. Not the same as that. Why would that be the case?
There's like 4.1, 4.2.
Exactly, all the decimals that exist between 4 and 5. If I say, well, I'm excluding the 4, so I'll just start at 5. Well, then you're losing, there are actually infinitely many values that exist between the number 4 and the number 5. It's hard to think of it because it's a finite space, but you can always work with smaller and smaller fractions in that interval. So there are infinitely many values that exist between 4 and 5. You're ditching all of those if you just start at 5. All right? So be very careful about that. I'll remind you of that over and over and over again, but if you could try to somehow reason your way through that. And again, I'll just kind of chuck it off on the side here, and we'll only focus on the 4, here's 5, here's 6, and here's infinity. My 5 looks terrible. All right, here's 4 to infinity with an open circle. Here's 5 to infinity with a closed circle. So I would say if you started with a 5, I would be looking at these and say, and this is what I would draw on your test paper or quiz paper if you screw this up. What happened to all of these? Oh, that's not how you spell happen. Get rid of the evidence. To all of these. All right, you're just knocking them off. You're saying, I don't care about those. They don't exist. Well, fun fact, I care about them. So you need them.
Why does 4 have an open circle and 5 has a closed circle?
Well, that was given. What I was saying is that 5, if I were to think of this instead of as 4 to infinity, instead of that, I'd write it as 5 to infinity with a bracket. That would correspond to this graph. Open circle corresponds with parentheses. Closed circle corresponds with brackets.
Oh.
All right? And we'll see more, obviously. So you can see in this case, in the second one, how we have a closed circle, and that corresponds with a bracket. Infinity always gets parentheses. All right, so now I want to go backwards, write it as an inequality. So start with x. Obviously the number -2, because that's relevant. What's the relationship between x and -2? Greater than, less than or equal, greater than or equal, not equal, just equal, less than or equal to. All right, less than or equal because we can get to the number -2. We can be equal to it. I'll take this as a typo. Probably have at least a number line in here for you. Just a line. I don't want to put the labels on it for you because you might want to do it in a particular way, but I suppose I could have given you these. All right, and again, like I said, I just need 3 numbers on your number line. So something, one value to the left, one value to the right, and the number itself. So 3, I'll just plot it right in the middle. Put a 2 here, put a 1 there. What's going above the 3?
Open circle.
An open circle. Which way am I going? To the left. Arrow's pointing to the left. We're going to the left.
Wait, why does the number line go to 1?
Because I'm merely testing your ability. Yeah, that was there the whole time. I don't know what you're talking about.
Oh,
Yeah, I just made a mistake.
Wait, no.
My nibs aren't working too great. That's the excuse I'm going with. I just missed it. All right, so what is my interval? I'm using interval notation to represent the same thing. How would I write that? Parentheses. Negative infinity. We're working from left to right when we're saying our interval. So I'm starting all the way down here as far as this arrow will go to the left, which is negative infinity. And then I'm going as far as it'll go to the right, which is where? 3, as long as I do not, you see, that's what keeps happening. As long as I do not include the 3. All right. Now, if you compare this with what we just did above it, you see that it's very similar in terms of the structure. Open circle got the parentheses, closed circle got the bracket. All right. All right. So let's look at the next one, but let's do interval notation first. Where is that starting? -5. Am I including it or not?
yeah.
Yes. So what symbol does that get? Bracket or parenthesis?
Bracket.
Bracket. I'm going to the right somewhere. Where am I stopping? Infinity. If I can get there, I can't. So parentheses to indicate that we can never actually get to infinity.
I didn't know you could do a bracket.
Because it's included. It's a closed circle. Brackets get closed circles. Open circles get parentheses. The 3 here is not included. It's less than 3. All right, so the inequality notation. X and -5 are the values being compared. What's the relationship? Greater than or equal. All right, X is going to the right of the -5, and it's also including the -5. All right, we want to keep the X's on the left-hand side of our inequality wherever possible. Sometimes it's not easy to do that. Sometimes it's not worth it to do it. But wherever possible, we want to, because then the inequality will point in the direction of the shading. It's just a nice little thing to not have to worry about. All right, next one up, we have 0 to infinity. So let me label that off here. All right, above 0, I'm putting a what? Open circle. All right, shading which way, left or right?
Right.
To the right. We're going in the direction of positive infinity. Negative infinity is all the way to the left. Positive infinity is all the way to the right. So X and 0 are two numbers. Relationship? Greater than, yep. Right? If you draw the picture the correct way, then this inequality is going to work itself out. Because I know my arrow has to be pointing the same direction as the arrow on my graph. It's just a question of whether it's going to get a little equal sign at the bottom. If it's colored in circle, then yes. If it's not, then no. All right, so the number line for -1, for the last one, -1, I'll put a -2 here. I'll put a 0 here. What's going above the -1? Closed circle. Direction?
To the left.
To the left. Okay. So in interval notation, I'm starting off where? Negative infinity. Where am I stopping? -1, or nobody knows. Either one is acceptable. That's not true. Anyway, -1, am I including it or not? Yes, so bracket because we're including it. Closed circle. Including means that you can be equal. Equal means closed circle. Closed circle means bracket. All right. So now you see these problems below. They're essentially the same. I mean, maybe the difficulty level has increased a little bit, but they're essentially the same as what we've been doing. We have to solve for a variable, but this time we have to state the solution to our inequality in interval notation rather than that funky set builder notation. All right, so my first move would be to do what? Distribute. That's one good first move. Otherwise, you could have done what? Not divide. Subtract. All right, so distributive property. But now that we've distributed, I mean, we might as well combine like terms. So 12r minus 13 greater than or equal to 8r plus 3. Now what? Plus 13. And simultaneously we can do, we added 13 to both sides. At the same time we could have done what?
Subtracted 8R.
Subtract the 8r. All covered under the addition property of inequalities. So 4r greater than or equal to 16, relatively clean, not too bad. Sometimes fractions work their way in, just be on guard for that. This is not one of those times. I mean, in terms of a solution, it looks like a lot, but when you think about the actual skills involved, it's not that bad, because it didn't involve fractions in terms of the equation, and then a fractional answer, which is a little bit jazzier, but in this case, it's not too bad. All right, so the interval notation version of this would look like what? What am I starting with?
No.
4. And where am I going? To infinity, because any value bigger than 4 is fine, right? We know infinity gets parentheses. What kind of fencing? We call it fencing when we deal with brackets, squiggly brackets, parentheses. It's called fencing. What kind of fencing does a 4 get? The bracket. All right. Now, it may be easier for you to see that if you create the number line. If you're looking at that 4 comma infinity and you're like, okay, I have no idea what you're talking about. If that's the case, then make the graph first and draw the closed circle above the 4, shade to the right. We have 3 and 4, 5, right? Just to establish the scale. I have an infinity over here. All we're thinking about is, where am I starting? Where am I stopping? All right, we're starting at the 4. We're stopping at infinity if we ever get there. We can't ever get there, so we put parentheses on there. We are definitely stopping here at a solid point at 4, so I put the bracket on the 4. Oh, that's not the scrolly thing.
Are we gonna do a test back?
Ah, I'm in a groove here, teaching a lesson. What are you doing? It's like in math teacher mode. Are we getting our test back? Oh, heartbreaking. No, we're not. You're gonna get grade slips though. I still have one student, just one student, who hasn't taken the test. So
Wait, does our grade slip have the test grade on it?
it does,
Oh.
but it doesn't have that satisfaction of knowing where that grade came from. So,
Yes.
so sorry about that.
No, it's answering.
We have to have them in by Thursday, I think. So then you should have them by the end of the week, maybe early next week. All right, so number 9, we're going to skip to number 9. First move should be what? Thanks for that. Multiply by, you said? 8, yeah. Each part. 8 is the LCD, so let's multiply through the 8. It'll cancel. Then leave you with 7p minus 2 less than or equal to 4p. All right, so each part, if you need to show the work, show the work. But this, multiply by this, then this, multiply by that, and this, multiply by that. I multiply by a positive number, so I don't need to change the signs. I'm going to subtract off the 4p for both sides. I want the p's on the left, but then simultaneously I'm going to add 2 to both sides. It's a weird looking thing, but it still works. So we're looking at 3p less than or equal to a positive 2. The right-hand side zapped down to 0, these two guys. That became 0, so 0 plus 2 is just the 2 left over. All right, so it looks like we're getting a fraction here. So let's divide out the 3. And so P would be less than or equal to 2/3. So fractional question, fractional answer. Let's do it this time where we do the number line part first. I know 2/3 is between 0 and 1. I'll just get, again, 3 values to establish scale. I'm going to estimate where I think 2/3 is. All right, it's most of the way between 0 and 1, so that's like right meow. You just chuck it in there. What kind of circle goes above the 2/3? Closed. Which way am I shading? Which way? To the left. And again, I could just follow the direction of the symbol here. I can only do that because I have a variable on the left-hand side. If I had a variable on the other side, I'd have to make an adjustment. All right, so now that I have this information, I'll chuck in a negative infinity over here so you have it. Interval notation would be what? Where am I starting? Negative infinity with parentheses. Where am I stopping? 2/3 with a bracket. Always reading your number line from left to right. I mean, the question is going to be to distribute or to not distribute. If we're not distributing, then you may consider dividing out one of these two things, but 2 and 3 don't divide evenly into each other, so I recommend, in this case, distributing, but don't always think that you have to distribute. Don't be a Sally. All right, so 2h plus 12 greater than negative 24 plus 3h. All right. For the most part, we want to have variables on the same side, but specifically on the left. So I'm going to bring the 3h over, even though it creates a negative. Then I'm going to bring the 12 over. I honestly don't care what kind of number that gives me.
Don't you get the same answer if you did the opposite way?
You would. The only issue with doing it the opposite way is that the variable will be on the right, and you may have to do that extra thinking step to get it in the right form. But so we have negative h greater than negative 36. I don't know, lots of things happen when you squeeze your hand. It could be a circulation issue. It could be.
Dude, I don't know. It's pretty cool.
Is the color change that you're talking about?
It's all like wrinkly. Like it makes me look
Oh,
like
like pickle fingers kind of thing?
What?
Like when your hands get all pickly when they're supposed to
No,
water?
like this. That's all like,
Oh, that, the extra, the loose skin, yeah.
yeah.
It's all getting compressed. Yeah, that's pretty cool.
It's like when you go, I mean,
Divide by negative
I guess 1.
uno. So h will then be less than a positive 36. All right, we can graph the solution. I leave that up to you. If you have trouble understanding why brackets, why parentheses, how we get those numbers in interval notation, then sometimes, I can't promise anything, but sometimes, and people have told me this in the past, doing the graph first has been helpful. So let me put in a 36 here, I'll put a 35 there, 37 there, just a few values. Open circle above the 36. Shade going in the direction of the left. We know on the left-hand side we're looking at negative infinity. So that's telling me that my answer in interval notation would be what?
Parentheses, negative infinity, comma, 36, parentheses.
are any of these answers gonna have a decimal?
Parentheses, I got it.
Decimals and fractions are fair game. We're working towards those, yeah.
In number 7, I think I got a decimal, and I think I'm wrong.
Alright, we're not on.
Yeah, you need
Yeah,
to
I'm wrong.
take another look at that.
I completely.
I have 30 over 4 instead.
Don't worry, I'm just stupid.
Nah.
I did 13 plus 3 equals 26.
We'll look at it. Hang on, number 10.
Yes.
Folks, what I recommend you do in order to kind of stay where I'm at and not lose any, I think my instruction's valuable. That's why I'm standing here. If I didn't think I was telling you anything that I thought was useful, I probably wouldn't do this. I recommend sitting tight on moving forward, regardless of how much you want to get the homework done and out of the way. Because odds are, I'm not doing the problems in class that you want to do. So if you go ahead and you do some problems, that's wonderful, but then if I'm ready to move on to number 10, I'm really not at a point where I can answer your questions about number 13, number 15, whatever you decided to move on to. So sit tight until at least I get through the instructional portion of what I'm trying to get done, and then I'll be happy to answer any questions you have. All right, does that make sense? No?
Yes.
Man, I'm pulling an O for today.
I understand.
All right, because you didn't understand the seating thing, you didn't understand the grading. All right, so in the previous question, this is why I chose these two particular questions. Before, it made perfect sense to distribute. Here, I don't want to distribute. I want to divide out that -2 first. If I do that, then I don't have to worry about distributing. Oh, if you like distributing, that's a different story.
Then you don't get the right. But if you do distribute, you still get the same answer, right?
Yeah.
Not for this one. What's the last one?
I mean, you're not really trying new things, and if that's happening, it's like, yeah. So you know one way.
Negative.
I screwed up?
It's 4.
You have the sign.
Oh, I went the wrong way? Thanks. Good catch. That's the other byproduct of when I get distracted. the things start
I didn't
happening.
even notice that.
That's like me when I caught it.
So each part here has to be divided by the -2. So I'll have -3x minus 1. Why does the sign get flipped?
Divided by a negative.
Well, yes, and yes. Yeah, you're dividing by a negative. If you multiply or divide both sides of an equation by a negative, you always flip the direction of the sign. This is a beautiful situation here. Because if I add 3x to both sides,
Settle.
cancellation, right? Now, in equations, very important concept here. I get this relationship. In equations, if I get any difference from left to right, I would say no solution. Here, I need to make sure that if I get different numbers, that it's still, I have to determine the truth value. If it's true, when I get down to just numbers, variables cancel away. If the remaining statement is true, then my answer is all real numbers. Because then it would mean that no matter what I put in for x, it's always going to work. If when I get down to just numerical stuff, so variables cancel away, if I get something that's false, then it means no matter what I put in for x, it's never going to work. Never going to work. This is a false statement.
No solution. No, don't say false statement.
Therefore, empty set.
That looks so cheesy.
You could also go with the no solution symbol, the circle with the strike through it. But the one thing you don't want to do is even look at this number line. You draw any lines on this number line, then you're wrong. Because then you're telling me that there is some solution. You want to leave this completely blank. And that's kind of, not confusing, but it's troublesome because on a test, you want only what you need to answer the question. So when I put this here for a question that doesn't have a solution, the instinct might be to raise your hand and say, do I need that number line? Because I got no solution. And then I'd be like, okay, everybody cross off number 10 on the test because Johnny ruined it for everyone. And now those 2 free points you would have gotten, nobody's getting them because he just gave everyone the answer.
Or what if they got it wrong? It's not 2 free points.
Then I'd be like, listen, everybody, don't listen to Johnny because he just told you something that's completely and totally wrong. Johnny, maybe you should write that down so you can run the
So wait, does that mean there's no interval notation?
There's no interval notation because if we put something in there, then we got a problem. So that's why we use the empty set to indicate that there's nothing. All right. Or at least that's the preference. Dreadful. Made you want to cry? I'm gonna get a full-blown answer key up in a little while. I put answer keys to everything relevant except for this page because, yeah.
Because the perimeter has
I'm gonna give them back at the end of class. Because now I officially have the last person to.
You have to do on one side.
For what values of x is the area
Area and then the other side.
of the rectangle greater than the perimeter? All right, so let's focus on area for a second. Area. All right, what is the formula for area of a rectangle? Length times width. We want that to be greater than perimeter,
Which is 2 times length.
which is equal to 2 times length
Plus 2 times width.
plus 2 times width. All right, 2 lengths and 2 widths added together. So as long as we can come up with some expression that satisfies this relationship, we're going to be in good shape. So we're going to designate one of these sides as a length and one as a width, because as you know, hopefully, it doesn't matter which one you call the length and which one is the width. Size matters not. So I'm going to let the 7 be the L. And I'm going to let the x plus 2 be the width, and then I'll have this expression. Well, these two expressions, which in turn become my inequality when you put that little symbol in between. All right, so now I'm going to do a little distributive property. Straight up multiplication here, right? Oh, bad squiggly bracket. Oh, look at that. It's a good looking squiggly bracket now. Plus 2x plus 4. All right, got some like terms here. Put those together. 7x plus 14 greater than 2x plus 18. Way easier now that you have an actual expression to start with. Subtract. Subtract. Go to you.
I'm tracking you guys down, for sure. You're welcome.
Special delivery.
You weren't not my last grade, you're not my last grade yet. Sorry, my last grade. You can have 2, Lexi, if you want to.
No thanks.
Double the fun.
Yeah, exactly.
The homework sheet, right?
Sorry, Mr. Can.
Ah, it's no big deal. You're always welcome. Ah, we're gonna have an in-school field trip. You can come in and tell stories and everything.
How many good stories?
Wow.
That's like the smart time.
Put it on your list of things to do. I mean, break up the monotony, you know? Oh, man.
Is that the good one?
I can't say.
All right, so
The more advanced one.
when my friends come walking by, I get distracted. So I probably just screwed up this whole problem.
No.
No, I'm looking good?
No, you're good.
I mean, the math is looking good?
Yeah.
So divide by 5. So we get x is greater than 4/5.
Yesterday you said that we're not getting into fractions yet, so when I got to fractions, I was like, well, shoot.
Did you say where?
Wait, what did you say?
Not like the fractional expressions with variables on the bottom. Those are the fractions that I was really talking about. Yeah, those are called rational functions, and those are a nightmare. Actually, they're not that bad. I needed something to call a nightmare, and that's what I chose. Do we have to do anything more with this? I didn't read the directions.
No, it was just to write and solve an inequality algebraically.
Boom, shakalaka.
You
And
have
graph?
to graph it.
It says graph at the top.
At the top?
No,
There's no graph.
no, there's no graph for every other question but that one. You have to graph it.
Oh yeah, word problem. So we're changing the rules. Okay, all right.